All right, welcome back. This is the last talk of the second session on day one of the iRODS user group meeting 2020. We are all at home. This is going to be Nils Haustein from, he's in Germany, he's at IBM, and he's going to talk about the integration of iRODS with the Spectrum Archive from IBM. And this is also work being done with Mauro at the Euro-Mediterranean Center on Climate Change in Italy. There you go, Nils.
Thank you very much, Terrell. Yes, in this talk, I would like to present the work Mauro Todici from the Euro-Mediterranean Center on Climate Change in Italy, and I have done last year. We actually, integrated iRODS, with tiered storage file system, and one tier being on tape, which makes it a little bit more challenging, and we also call that an HSM managed file system. Clearly, Mauro drove this work because he had requirements from his user and the project, to get things done, and usable for his users. Last year, Mauro and I worked together to implement an HSM managed file system based on IBM Spectrum Scale or GPFS and IBM Spectrum Archive for CMCC. And during that time, Mauro clearly understood the challenges when using tiered storage with a tape tier that is HSM managed. And based on this, Mauro came up with this brilliant idea to use iRODS to cope with these challenges, and he actually, set us up a test environment with iRODS and Spectrum Scale and Spectrum Archive. And we both worked together, and did some implementation, and that is the work I would like to present in this talk, okay? Now, I would like to start with the challenges of HSM managed file systems, and then demonstrate how we solved that using iRODS on top of this HSM managed file system comprised of IBM Spectrum Scale and IBM Spectrum Archive Enterprise Edition. An HSM managed file system, resides in different tiers of storage, like flash, SSD, disk, tape, even object storage, and as you see in this picture, placement, there are different rules, placement rules define on which of these tiers, the data is stored when it comes in, when it's being created. Migration rules define, what is going to happen with the data, with the files during the life cycle, when should they be migrated to the next tier. And placement and migration are fully automated by HSM essentially. The user can access such a file system, through standard file system interfaces like, POSIX, NFS, SMB, S3, whatever, And the user can also see all the files in the file system, regardless on which of the tiers the file resides. When the file resides on tape, like in this example, in this implementation here, then the user accesses the file which resides on tape, then the file is being recalled, from tape to disk or to flash, and then the user access is granted to that file. That all happens transparently in the background. Now, there are some challenges, with HSM managed file systems, and in my work at IBM, I really try to address many of these, tapes as storage tiers, that is one observation, I have, the tapes as storage tier in an HSM managed file systems are a blessing and a curse, Files on tapes are visible in the file system namespace, even though they are on tape. That is obviously very good, and used to be a key selling point for HSM managed file systems, Access to files on tape cause transparent recalls, and that takes some time, right? And now a little bit, cursing starts, and it gets even worse if many files are accessed and recalls transparency. So just imagine a user copies like 100 files, 1,000 files from a directory, and these are all on tapes, then these files will be recalled from tape individually without being sorted, So we see a lot of tape motions, tape being mounted, unmounted. We see a lot of start, stop motion on the tapes, and this makes tape operations really slow. Unfortunately, and that's another disadvantage with this, the user doesn't easily see whether a file is on disk or on tape in such a HSM managed file system, right? And another disadvantage, if you talk about multi-user systems, something like Mauro wants to set up for his institute, is, that there is no no user or group quota for the tape tier, so users just store data, whatever they can, it's being migrated out of tape, and Mauro and his team have to buy tapes, like every other month, right? So these are some of the key challenges, and in conclusion, we can say, that clearly not all files are suited to be stored or to be tiered on tape, right? Especially files that are frequently accessed, why would you put them on tape, because they will be recalled all over the place. It doesn't make sense, Also files with a short life cycle. So if you want to keep files for a month, why worrying about putting it on tape, I mean, the key advantage putting the files on tape in the tiered storage file system is the cost advantage, because tapes are less costly than spinning disk, um, and also many small files, it doesn't make sense, to put them on tape, because the tape operations have much more latency than disk operations. So things are getting really slow then. Another observation is, that standard file systems like POSIX, NFS, SMB, and the like are tape agnostic. Users have no simple way to see if a file is on disk on tape to start with, right? So they access the file and then they see nothing happens, right? The file doesn't come back. Okay, so what are they going to do, right? Another thing is, when the user accesses a file or when the user accesses multiple files, these files are not recalled in an ordered way from tape. So the files are not sorted by their tape ID and the actual physical location on the tape, but they are accessed they are recalled or restored from tape in the order they are accessed, right? And this order doesn't match the order they are stored. So we see a lot of tape motion, start and stop motion, tape mounts, and stuff like that, which makes things really slow, as mentioned before. When the user has access to the file, which is located in tape, as I mentioned before, he doesn't see the progress, right? I mean, it just seems to hang, because this access operation is intercepted by the HSM software. The HSM software is going out to the tape, loading the tape and doing all these tape operations, which are slow, and users just, getting impatient in front of his workstation. And as mentioned also before, there's no user and group quota limit for the data stored on tape only, which makes it really hard for the admins to control, what's being stored, how much is being stored by user, and stuff like that. And these are the key challenges, with tiered storage file systems. I not only observe that with the IBM products, I observe this with other tiered storage or HSM managed file systems as well, and but there are solutions for that. That's the good thing, right? And one solution really is iRODS. You probably know iRODS much better than myself and Mauro. We started last year, or end of last year, to dig into the iRODS software and documentation and find ways to, implement our requirements. But in a nutshell, what we understood, the iRODS software is a data management layer. It sits above the storage and below, the domain-specific applications. It thereby virtualizes data stored in heterogeneous storage systems in a single namespace. And it's a software that is maintained by the iRODS consortium as a open source software. iRODS enables users to access, manage, and share data across any type or number of storage systems, which is really interesting and good. And it has APIs to, different APIs to access and manage the data on the storage, right? Even more, interesting are the powerful rules and microservices within iRODS, which allow to automate workflows, and stuff like that. And we have used some of these some of these rules and microservices in our implementations, as I will show you in a couple of minutes. Another interesting thing, especially for research data, for data which has to be kept for longer periods of time, like archive data, is that you can search and find data. You can add descriptive metadata information to the data, and find data later on. You can even automatically, harvest, metadata from your data you have stored, and put it in the iRODS catalog, and which can be, this metadata can be used later on to, find the data. That is very important, to find the data, especially for archiving. Okay, now the integration of iRODS, with the IBM product suite comprised of Spectrum Scale and Spectrum Archive is shown in this little picture here. So we essentially created an iRODS server, with the iCAD catalog, and we have an iRODS client as as our simulated application. And here we have a Spectrum Scale file system, which is HSM managed. This Spectrum Scale file system is provided, via NFS to the iRODS server, which also runs the storage services on it. So the iRODS server sees an NFS mount of the Spectrum Scale file system, and underneath in the Spectrum Scale file system, we have a disk tier and we have a tape tier, and the migration and the recall between these tiers is managed by Spectrum Archive. Actually, the migration can be managed based on policies. For example, you can say, well, data which has been stored on disk and hasn't been accessed for 5 days is going to be migrated, to tape. The recall aspect here, there are actually 2 types of recall. One is the so-called transparent recall, when a user accesses the file in the file system, then this file is being transferred back from tape to disk. The user can access the data. And there's another way, an alternative way, which we leverage in our implementation. It's a so-called tape optimized recall, right? So the tape optimized recall, is not based on the user access, but more on an administrative command or a scheduled process, which essentially takes a list of files, sorts these lists by their tape ID and the position on tape, and then gets back these files from the tapes in parallel. The only limit you have is the number of tape drives, essentially, right? But it streams these files back in parallel, in a tape optimized way, so the tape keeps running and doesn't have to stop. iRODS provides powerful rules to intercept data operations and execute workflows. This is one thing which became obvious to us, and we used actually these rules and workflows, to address the challenges I mentioned before for HSM managed file systems. And here are the implementations in a nutshell, which we did. So one of the key aspects is this transparent recall, especially if a user accesses hundreds of files transparently in the file system, right? So what we really want to do is we want to recall these files in a tape optimized way, okay? So we created, we used custom iROD rules to intercept the open request for a file, We check the file state in the Spectrum Scale file system, whether it's being archived, whether it's being migrated or not. And if the file state is migrated, then we add this file name, the name of the file, into a queue located in the Spectrum Scale Spectrum Archive server, and present a message to the user, that the file cannot be accessed right now, right? So as you see here in this example, in this first box, we do this iGet for this file 1, and the user gets the message, that the file is still on tape, it's being queued for recall. Of course, this queue needs to be processed, and it can be processed by a scheduled process in Spectrum Archive, which goes over this queue, according to certain periods of time, and sorts these files and, according to their tape IDs, and brings it back to disk, right? With this scheduled process, you can also establish SLAs with your users, where you can say, well, user, if a file is migrated on tape, it may take 1 or 2 or 3 hours before it gets back, But with this, the user has clarity what's going to happen, right? And he doesn't wait and wait and wait, Another, to address another challenge, with regard to the file migration state, we implemented a program, which essentially displays the file migration state. With this, the user can determine, whether a file or a set of files is on tape or not, right? So actually, we implemented a new user command. We call it iFileState. Sorry, iRODS Consortium, we didn't inform you about that, but it's really, a simple implementation, and probably doesn't fit your purposes. But essentially, this command executes a custom iRODS rule, which determines the file state and gives a message back to the user, which says the file is migrated or the file is not migrated. As you can see in these two examples, in the first file, the user sees this file one is migrated. Now, file state can also be invoked with the -a option, which means show me all files in the current collection or in the current directory, um, and then you see the file state of multiple files, right? So you see file 0 is not migrated and file 1 is migrated. Okay, so with this, the user really has the capability to see whether the file is migrated or not, and he can act on that, right? He sees the file is migrated, well, I need it. I may have to wait a couple of hours, but then he does the iGet, and sees the message, the file is being queued for recall. Now, lunchtime, let's go have a coffee or something, and after lunch, the file is back, okay? Okay, there are two other integrations we did in accordance to the requirements. Mauro and his team had, one thing is setting the quota for the entire file system, including the tape tier. We leveraged integrated iRODS rules for that and some level of automation, which is integrated with iRODS. So we enable the quota, in the core RE file. And then we created and loaded a delayed rule, which periodically checks the quota for the user, and then we set the user quotas according to the values required. And this actually proved to work. If the user stored more than, I think this 2 gig of data in that collection, then he got a message that he ran out of quota, even though 1.5 gig of that data was on tape. And yet another interesting implementation we did, and this is based on existing code and an existing project, is to automatically add file header information to the iRODS metadata catalog. So again, we leverage iRODS rules to get informed after a file has been closed. And once the file was closed, we harvested, some information from that file, and added it to the metadata catalog, using some customized code. Essentially, this project was based on the GitHub project shown with this link here. Okay, so these are 4 implementations we did, which I think are very well suited, to address the challenges with HSM managed file systems. And you can even do much more with iRODS, depending on your requirements and so on. So in summary, iRODS allows you to address key challenges of HSM managed file systems. You can prevent transparent recalls, which are not good, they are slow, and perform tape optimized recalls instead. At the same time, you can provide, clear SLAs to your user, how long it's going to take to get files back from tape, right? And this SLA is expressed in the number of hours, and that's the time period or the time interval for the scheduled tape optimized recall process to run. This integration allows users to display the file state. It allows applying quota settings for the entire file system, including the tape tier, and the automatic insertion of metadata based on file type and content. It is also interesting, and it's relatively quickly implemented, depending on how much you're familiar with programming and with your file formats and stuff like that. Furthermore, the capabilities of iRODS allow you to build and manage your archive efficiently. You can create a global namespace across multiple storage systems, which are even located in different locations. You have this metadata governance, centralized metadata catalogs, which enable the users to find their archive data later on. The rule engine with flexible policies allows custom integrations and workflows, as I have demonstrated before for this HSM managed file system challenges, and with the standardized interfaces for data access and administration, it enables efficient data sharing and collaboration with data. Okay, so this is the end of my talk. Are there any questions, Terrell?
Very good. Thank you. There are a couple questions. I think we'll first go to the hands up. So we've got Mohammed from Bristol Myers Squibb. I think if he unmutes, he can ask a question.
Hello, great presentation. Quick question, which is, in the same realm as what you present. If we want to move the data in a similar fashion from S3 to Glacier, or from our local storage directly to Glacier, can we use something, and is it something available on GitHub?
So where's your data located right now?
So our data is located on on-prem NAS and also on S3.
Okay.
And the data on S3 is indexed and is cataloged in iRODS.
Okay, and you want to move it directly to Glacier from that?
Yeah, the ones that are on S3 we can move to Glacier, but if it is through similar process, we would have iRODS track it as well.
Okay.
But we also have a separate need for NAS data directly going to Glacier.
Okay. Well, I cannot really answer your question entirely because, the migration, and in this project I presented, the file migration is managed by Spectrum Scale and Spectrum Archive essentially, right? So this is the file system, right? So
yeah. Why I said it's
you are probably looking for something where you have iRODS on top of the NAS system, the NAS system being a storage resource in iRODS, and then use iRODS to move the data, because you really want to physically move, right? I mean, once the data is in Glacier, you want to delete the instance I can imagine it's possible, but I cannot answer the question what to do. Maybe Terrell or one of his team members knows.
Okay, all right, thanks, yeah.
I will say that that's probably going to require more detail. But yeah, I think most things are possible. The question is, does it make sense and is it efficient, right?
Yeah. We do it outside of iRODS, but going through iRODS would be preferable.
Right. Thank you, Mohammed. We do have a question, says from Alan, are you guys using group quotas? How do you manage that against user quotas versus resource quotas? Does that, I think you talked about quotas here in this talk as well.
Yes. As far as I remember, we did user quotas. We didn't focus too much on groups, but maybe Mauro, who is in the conference and he can use the general chat, maybe he has tested group quota. I think group quota is important for his organization. So maybe Mauro can answer the question in the chat.
Fair. Yeah, I think we've found some trickiness when if both are in flight at the same time. Between users and group quotas, they have some differing opinions on what should count. So we have a talk later about logical quotas.
Okay.
Later in the conference. A couple other questions. Where can I find more information about iRODS resource quotas? Okay, we can answer that offline. And how rebalance is affected by getting the data from the tapes? So I'm assuming this is in context of an iRODS rebalance. Do you know the answer to that question?
No, we haven't thought about that.
Okay, yeah, because as far as I can tell, this is everything that you've just presented would be visible to iRODS as a single resource. And so a rebalance would be, from our perspective, a level higher logically. So we would have, one would be in the archive that you've talked about, and then it would be in a separate system would be another replica.
Okay. Yeah. But so rebalance has to do with replication then, or?
Yes, it has to do with what we call replication, which is keeping multiple physical copies in sync across different technologies.
Okay. Well, I think in this setup, as I have shown you in this one picture, I mean, iRODS sees one instance of the file, and this instance of the file can be on disk or can be on tape. So you can probably have two instances of that for data protection, for example, and both have this tiered HSM. I mean, this HSM managed file system, and then both would work independently. You may recall on one system but not on the other. But for iRODS, it's iRODS in this case would see two instances of the file, but they are managed really from the underlying file system.
That's right. Yeah, I think that's how they would fit together. We do have a question. Oh, a comment from Jason Kaposky. He says we have had trial integrations with Glacier via the S3 plugin. So Mohammed, we can talk about that separately later. And one question from Dehan: are garbage collection and recalls delegated to IBM Spectrum Archive?
Yes. Okay. Garbage collection, reclamation, reconciliation, that's all run underneath iRODS. iRODS doesn't see that. iRODS sees the file, and whether the file's on disk and tape, we manage this independently. Yeah.
Very good. We are at time, and I think if there's no more questions, let's see. French National Library is saying that we use iRODS and IBM Scale Archive for our preservation system. So there you go. There's a vote of confidence.
Wow. Okay. Well, let me know if you need help with that.
Dehan has raised his hand. Dehan, do you have a follow-up? Let me allow you to speak here for a second.
Yes, do you hear me?
Yes, we can.
Yes, in connection, hello everybody, Dan, KTH, Sweden, Stockholm. So my question was, once you recall the file, is that one presented to iRODS as an additional replica, or just the state is updated as available and migrated through the attributes?
Well, actually, we don't track any information in iRODS, whether the file is migrated or on disk. I mean, iRODS tries to access, if you do an iGet, it tries to access the file. Well, it doesn't try to access the file, it checks the file state first. To check the file state, we use the stat command, right? So we use the stat command, and if the file size is greater than 0 and the allocated blocks are 0, then the file is migrated, right? So this is a simple hack. And maybe I should add, we put, some links into the general Slack channel, some of the links we have embedded in our presentation, and there's also a GitHub repository, Mauro and I put together with some samples, where you can see the rules, and some of the processes and stuff like that. So if you're interested, have a look, please.
Very good. Thank you so much. We are at time, and we do have some more follow-up in Slack, so I'm sure that we can get more questions answered over the next week. Thank you.
Thank you.